Hello, Stuart Smith from Berkshire Guitar Amplifier Repairs, and I have a treat for you today. We have a Marshall Bluesbreaker. I've never had one in any workshop before. Lovely old amplifier, and this is a great example of the amplifier. I'm going to read from the crib sheet here. Apparently it's called the Bluesbreaker because Eric Clapton used a very similar amp to record the Beano album with John Mayall and the Bluesbreakers in 1966. Apparently he insisted on having it flat out in the studio, much to the disgust of the Decca engineers of the day. Now this amp has been acquired by my customer 2 years ago and he's never even switched it on, and we're not going to switch it on either. It's a JTM45 2x12, also known as a Bluesbreaker, 1966, model 1962 Series 1. Now this has got a list of problems with it. I'll read them out to you. Apparently the indicator lamp is not working. It needs a new filter cap. We have to wire in a replacement intensity pot and other unsoldered items. Ooh, what does that mean? Fit a new capacitor missing from around the middle of the board. Okay. Resolder cable to the base pot, and check the valves and obviously everything else. Apparently it's been professionally used and has been flat out for long periods of time, so the amp has had a bit of hard wear. Right, well, I'm certainly not turning it on. I'm going to take the chassis out and have a look at what's inside. Some of these things could be quite difficult, missing capacitors and other bits and pieces. Why are they missing? What's happened here? Okay, well, let's get the chassis out. I've never seen inside one, and I'm anxious to see what's under the hood. Well, here we are, top side. I wonder where Joan is now. If you're getting this message, Joan, call me. And Joyce, give me a call. So unusual, as I haven't seen one before. It's got funny old, I don't know what this is here. Some sort of anti-shock mounting there. A couple of preamp valves here. Some big old bottles here. Another preamp type valve following here. Strange. Capacitor. Rectifier valve, I guess. Oh, it looks fairly clean from the top. Going along the front, it's basically a JTM45, 4 inputs, a Mark IV apparently. Well, let's see what horror stories lurk underneath, shall we? Let's get this beauty upside down. I've got a horrible feeling I'm not going to like what I see. And I was right, I don't like what I see. Gordon Bennett, what's gone on here? So we've got a couple of filter caps here. Can that be the original position of them? Just bouncing around there like that? I'm going to need to do some research on this because I've never worked on one of these before. I've got this hanging off here. I'm guessing, yes, this is the intensity pot here, right hand one here. As you can see, that's not wired up, so this gubbin somehow goes onto here. We've got a broken earth strap there. Oh, I presume that just goes, yeah, that's where the old intensity pot was taken out, so that needs to go back on there. We've got, oh yes, this is our new indicator lamp which is fitted, and that needs wiring in. Okay, what else have we got? We've got a 10k resistor hanging off here. No idea what that's doing. Can this... what on earth is all this lot? Can this be right? What is this transistor here? Surely that's not original, is it? It's got a transistor dobbed in there. This capacitor's hanging off, look. Not sure what's going on here. We've got lead here hanging off, going nowhere. No idea. This is going to be unless I can get some good diagrams and things on this, is going to be quite tricky. Anyway, continuing along the board, they're almost certainly the bias capacitors. They will definitely need replacing, and we may as well do this and this whilst I see them. Everything else looks sort of okay. And then on the valve bases, 100k. I'm not sure what this valve is. I must find out what's going on here. Quite unusual to have a preamp valve after the power valves, or on the other side of the power valves. There's the filter cap from the top side, and then there are these X joints here. Hard to believe this is how it should be, but who knows. We will definitely want to be replacing both of those filter caps as well. This one's probably okay. The can't see any evidence of leaking there. Mains lead with the good old cable tie and knot routine. Well, at least the mains goes through. Oh no, the mains goes through the fuse and then to the off-on switch. Ideally, it should go to the off-on switch first. Anyway, I'll have a think about maybe changing that. What have we got here? This is the the foot switch comes in here. Getting a good old knot. Yeah, dear. Speaker socket, I think that's probably, yep, speaker socket. Voltage selector, I'll check that's in the right position, I expect it is. Pots feel reasonable. Yep, not seized or anything. Yes, the main issue with this amp is going to be working out what's going on. Working out where this goes, where's this wire coming from. Is this transistor original? What's this 10k resistor hanging off here? And all of this can take time, that's the problem, to do the research to discover what's going on here. This transistor here is something to do with the foot switch. So I think they're using this to switch. It looks like it might short circuit this resistor or something. I don't even know what the foot switch does. That I would have thought it's supposed to go down there. Why has it been taken off though? And it hasn't. I don't think that's fallen off. Possible, but anyway, that definitely goes there. I don't know where this 10k goes. Not obvious. Does it go across? It might go across here. To the, yeah, that's probably coming in off the, don't know. And then once we've got all the bits sorted out and back together, it'll be a question of going through the amplifier and finding out, you know, if it works okay, is there any noise, is there any hum. Don't like the look of this particularly. It's probably okay though. These have been replaced, so these are probably the screen resistors would be my guess. So they've been replaced. 470 ohms, 3 watts, that's a standard screen resistor value. Nothing else much seems to have been done to the amp. Right, so I think the very first thing I'm going to do is to pull up a schematic of a JTM45 Mark IV, if I can find one, and see how closely the diagram aligns to this. I might also see if there's anything interior shots of a Bluesbreaker. I just want to check that transistor, I mean it looks old, it looks like a 60s transistor. I just want to make sure that is standard, and also find out what the foot switch actually does. Right, bit of work on this one. Right, we have some diagrams, they're not accurate, in other words they don't relate exactly to the model we've got here. However, we can make a start here. This wire here that's hanging off here, that is coming off of the left hand side of the treble and floating around here somewhere. Now if we look at this schematic here, on the left hand side of the treble it's clearly showing a jumper across to the middle of the bass. Here's the bass pot here, and oh, you can't quite, can you quite see that? You can't quite see it, it's underneath there, and basically this wire has fallen off there. Let me show you that. So here's the wire coming off the left hand side of the treble, just hanging loose in the air. There's the base pot there, and there's the centre of it, which has nothing whatsoever going to it at the moment. So I reckon that this just goes onto there like that. So I think we can do that as our first little job. At least we'll feel we're making some progress. Okay, so we can just pop this one back on here. And that's the first little repair. Now I'm making a very careful note of the repairs I do, because when we come to switch this amp on, if it doesn't work and I'm thinking, oh, 2 days ago was it this lead I soldered onto there, or what, wasn't there a loose wire here and didn't I put it somewhere? And you know, you can't undo what you've done, so I'm making very careful notes on what I do. Right, so that's one job done. Right, the next thing we can do is to identify this valve here, which is, if you remember, is the one on the other side of the power valves. I think it's to do with the tremolo. This diagram isn't the same as the one we've got, it's not identical. However, the layout of the valves is, we've got 1, 2, 3 preamp valves, 2 KT66s, mysterious valve, smoothing cap and rectifier. And on ours we have 1, 2, 3 preamp valve, 2 KT66s, mysterious valve, smoothing cap and rectifier. So the layout is the same as this. So mysterious valve goes off to some bit of circuitry which has some 1 meg resistors around it, and it says 25 microfarad 25 volt cap there. So I think this is the tremolo oscillator, especially as it's got these phase changing caps here. Now we can go to the schematic, which is, I think, fairly accurate to what we have here. This is a JTM45 schematic for tremolo amps, and here we have mysterious valve, and look, we've got a couple of 1 meg resistors. It says 50 microfarads here. I reckon that's the 25 microfarad one on there, and we've got these phase changing caps. So this is the tremolo valve here. That's useful to know. The other interesting thing I've discovered is, if you look at this gubbins hanging off here, which goes to the intensity. By the way, of course, that's tremolo intensity. You'll notice there's a 33k resistor hanging off there. Don't know if you can see that there, going to ground, going to the screen. So we've got a 33k resistor to ground somewhere, and we've got a 10k going to a 0.1 in series of the 0.1 somewhere. So let's have a look at this schematic here. This will be the frequency control, and this, I believe, will be the intensity control. This 50k, in fact, let's just check that. Is that a 50k pot they've got in there? It's got no markings on it, so I'm just quickly going to check. Useful to check they've put the right pot in anyway. So that's 500k. What does that mean? Does that mean that they put the wrong... This has obviously been changed, that pot. It was faulty, I guess. So that pot is either incorrect on the schematic, which I doubt, or they've put the wrong pot in there. So we need to check that. But anyway, look, for the moment, let's not worry too much about that. On one side we've got a 10k, on the other side we've got a 33k. So look, we've got a kind of 10k floating around here, which, by the way, also goes to a capacitor, value of which I can't read. So we've got a 10k going to a capacitor going to one side of the pot, and we've got this 33k here, which will go to the other side of the pot, and doubtless this black wire here will go to the centre, and that will go off to the foot switch somehow, to be determined. So the thing we need to determine now is that a 50k or a 500k. Jumping ahead slightly, the other thing I don't quite understand is how this foot switch works, because it's got this transistor here. Hard to say which way round this is. It's a PNP, I think. But I don't see how this transistor's biased. It's blocked from DC via this 0.1 here, and it's blocked from DC via this capacitor here. So there's no DC path to this transistor that I can see to allow it to switch. So I'm afraid I don't know what that's doing. Don't quite understand that. To be determined. Hopefully it will just work. I don't have to worry about it. Okay, I think I'm fairly happy that this is the wrong pot here. Someone's put a 500k in, ready to be connected up, and I think they've just ordered the wrong value, to be honest with you. 50k, 500k, they've just misread it. The schematic calls for 50k, and it also makes kind of sense on the schematic. Just for your interest, let me show you this tremolo part of the circuit. Okay, so this is a tremolo oscillator. Anytime you see these three capacitors here in a kind of loop, that's doing the phase shifting to allow that signal to be out of phase by 180 degrees by the time it comes back to here, so that the thing oscillates. This is the oscillator frequency here. This is where the oscillations will come out of. By oscillations I mean tremolo, whoa, 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 whoa type of thing. So out of here we'll have a kind of quite a big sine wave. I'm not totally sure how this bit of the circuit works. It's a PNP germanium transistor, this. And for a PNP transistor to conduct, this must be more positive than this or this. It kind of conducts current that way. And of course this is ground here, and this is some higher voltage, so this is reverse biased all the time. The only kind of feeling I've got is that the signal here might be quite large and enough to take this negative below this rail at some point. In other words, to have this positive with respect to that, allowing the transistor to conduct. I think that's probably how it's working. Don't know. Anyway, this is the vibrato depth or intensity, and when it's wound up all the way here, you've got quite a short circuit almost between here and here, and when it's wound down to here you've got 50k in between here and here. So imagine it's wound all the way up to maximum. What you're doing is effectively, look, here's one of the volume controls. You're effectively putting a resistor, a low resistor from here to here via this conductive path periodically. So if you had a resistor, you'd be tapping on and off like that across that pot, and of course that would make the actual volume go up and down of the output of this pot, which goes off to the rest of the amplifier. That's how the tremolo works. And we have a kind of a mixer. Look, here are two inputs which come out here into this volume control, and here are the other two inputs which come out here on the second volume control. Right, so there you go. That's a little bit of it. I hope you find it interesting. So we need to source a vintage 50k pot for this. I'm going to spend some time looking around today to see if I can find one. Meanwhile, I'm going to just sort out this area here, and the customer has sent me 3232 capacitor on a clip, and we've got to kind of get that into here somewhere. I think originally the capacitor was in here somewhere. In fact, he sent me a photograph of the amp, and you can see that there's the capacitor there, look, just by the mains transformer towards the fuse. So it's kind of just to see. Of course it'll go this way. Lucky. Yeah, maybe when that's removed that will drop down. Anyway, let's do that. Let's get this rusty old bolt out and see if we can joggle this in. Right, these bolts are rusted in, and I don't have a nut spinner for them. They're not metric, so I've had to resort to the old mole grips and screwdriver routine. I put some WD-40 on them, and that's freed them up. Still quite tight. Surprising. Come on. You know you want to come out. Right. I think we'll keep those. We may reuse them, not because we want to particularly, but just for authenticity. That's like a... oh, what the hell that is? Some sort of graunched, half cut off washer with a bit of wire around it. I cut the capacitors out, that's the earthing for the capacitor. Yeah, great. We're certainly not going to do that. If you watch some of my other videos, you'll see you can get into quite a problem with earth loops on these old amplifiers. And I suspect one of the problems I'll have when we finally power it up is hum, which we'll need to somehow chase and sort out. And grounding stuff like this certainly doesn't help. There we go, that's come free. And here's the other attempt at grounding a capacitor. There was an attempt to ground a capacitor. That's an absolute rubbish way of doing it. Certainly not going to do it like that. Okay, well now we've got those bits out there, have we got room for this capacitor to go in? Oh dear me, that is tight in there. Just eyeing it up, just about goes under here, but of course we can't have this sticking up. Oh, we've got a couple of new nuts and bolts there, that's good, so I think we'll put those new ones in. And amazingly they almost line up. Well, actually I think they do line up with those holes, so that was original. Again, these holes are not good. Been made with a pointed stick and a mallet, not a drill, so we're going to have to get rid of this little thing here sticking up. I can't bear these rough old holes here. I think I'm just going to tidy these up a little bit. God knows what they've been drilled with. Absolutely bodged through they are. And we need to cut this off here, so I'm going to take a hacksaw across there, tidy up these holes and see how accurately this does actually line up with here. Okay, I've managed to grind off this stump here, so we are ready to offer this up. I've just had a look, of course, it's not so critical what sticks up out here because this is inside the case. I'm thinking of like a fender, you know, where this goes up underneath, but of course it's not like that with this amp. We've got acres of space. Right, so that goes up there like that. Might just go in. Let's have a go, let's just put one bolt in. Okay, I need to just open up this hole a touch, not much. That goes through okay, and will we... Yes, that's good. Okay, so that will actually go on there. Now before we get too enthusiastic, let's just pop this in here. And yeah, that's okay, that's going to work. Alright, well let's go ahead and put this in properly. We'll put this in this way now. 32 plus 32. Okay, so the negatives at the top and the two positives are there. So that goes in there like that. Yeah, that's nice, sufficient clearance there, and it's about 1 millimetre proud of the top. So we would have been okay. Nice and solid. Hey, that's the result. That goes in there better than I thought it would. Now these two positives of course can go onto the positives, and the negative I'm certainly not taking back down to here. There's a solder tag down here. I'm tempted actually to take both of these solder tags off here. It's not very nicely soldered here. Clean it all up and take the earth from here down to this, seems to be a spare solder tag there doing nothing. Take it down to there. Only when we power up this amp and listen to it will we know what the hum situation is. So I'm going to desolder these and get them soldered onto here, and I'll leave that for the moment. And then we'll get these solder tags off. This is a horrible arrangement, this mains cable. Really horrible. I do not like that at all. Okay, let's get rid of this old rubbish here. Just going to chop that off there. God, these are junk, aren't they? Well, I suppose they've done their job. That's 16 at 450 and this is 33 at 500, so it's just a random selection of capacitors somebody happened to have around, I think. What's interesting is this is 32 at 500, so that's actually quite a good capacitor. We can give them a little bend like this. Good. Nice. Now let's solder those in. And that's that capacitor in, apart from the earth wire, which we'll do next. And maybe I should have cleaned the tags on this capacitor before I put it in. I can see they're a little bit tarnished, but I keep a little pot of flux here, which is very useful stuff for this type of situation. Proper lead solder, of course, none of your modern rubbish. There we go, and that's in. So the next job is to see if we can get to these tags here. I might temporarily remove this mains cable. Don't like it anyway. Yeah, I might need to look at this, you know, because I think they've switched the neutral here, which I think they did do back in the day. I'm not terribly keen on this arrangement here. Apart from the mechanical securing of this, which is not great, the live look is going through the fuse holder, then off on this orange, and I think that just goes straight to the primary of the mains transformer. In fact, why don't we just quickly check that? I'm pretty sure it does. I think this goes to here. It does. So this amp is live all the time, even when it's switched off. Switches do nothing whatsoever on the front here. We have live voltage here. Neutral goes down to a tag on the rectifier valve, and I suspect that's just a spare tag they've used, and it comes off on this black here, and that goes off, and I suspect that goes to the power switch. Let's just check. Oh, can we check that? Yeah, we can. We can go from here to here. Yep. And when the power switch is on, of course, it comes out here. When the power switch is off, it doesn't come out of this one, so it's coming in here and coming out here, and that is then almost certainly going off to the the other side of the secondary. Okay, that actually took me quite a while to trace that. I couldn't work out where the black of the mains input was going. It wasn't coming out on any of these tags. Basically it goes up here to the switch, comes out of the switch and down to the voltage selector, which is kind of what I'd expect. It comes out of the voltage selector and goes straight in to the primary of the transformer here. There are no tags for it. This is the primary of the transformer going straight in here, which is why I couldn't find it on any of these tags. I was tearing my hair out thinking, well, the neutral's got to be on one of these tags here, but it isn't. It goes in here. Right, so anyway, that's, at least we worked out what's going on. The correct way this should happen is the live should come in and go to the switch, so that when the amp is switched off, There is no live terminals at all in this chassis. Next it should come via the fuse, then it should go to the primary of the transformer. That's the correct way. At the moment the live isn't even switched, it goes straight through a fuse into the primary of the transformer, and the neutral is switched via the switch, via the voltage selector, and then back to the primary again. We also probably ought to have a think about this. I don't like this at all. This is a no-brainer if you have carte blanche to bring it up to spec and do everything it needs doing, but this is a vintage amplifier, and so we know we have to be mindful about changing too much, because the purists like it exactly as close to possible as original. But there's been a few things changed anyway. We've got a new indicator light, we've got a new capacitor, we have new screen resistors already. The pot will have been changed, so I don't know, where do you stop? Rightio. Okay, I managed to find a replacement pot online in Hungary, so I've ordered that. That's going to be a while. Cost 30 quid as well, which is quite a lot, but there you go. So what we're going to do now is replace these two bias smoothing caps here. They're quite important to replace these, because if they go, the bias can go too far positive, and too much bias current can be drawn by the valves, and that either blows the fuse or makes the valve pop, so not great. These aren't in the signal path anyway, so we don't have to worry about any tonal effects. 10 microfarads, 100 volts these are. There we go, that's one done. Right, there's the second one in. Like I'm copying that angle there. There we go, so that looks quite like how the original was in. I don't think anyone's going to look at that and go, whoa, what's happened there? And these are also quite nice, these blue capacitors. They're not the more modern black ones, which do shout out a little bit. Right, now we've got those two in, I want to get rid of these. These can go into the goodie bag, which goes back to the customer. And we've got this one here. Yeah, I think that capacitor there is this one here, 50 microfarads. Unfortunately, it's a very bad drawing, this. You can't see what's happening. But it's across a resistor with a 1 meg one end, and I can't see what the value of that is. So there's this one here. This is 25 microfarads, not 50. Ah yes, look, it's got a 1 meg here, and so one end of it, the negative end of it, goes to a 1 meg and the junction of another resistor. This is in the tremolo circuit, so the positive goes to 1 meg and a junction of another resistor, which in this case seems to be 2K3 or something. Hard to read that second band. So we'll change this one as well. It's not doing anything signal wise. And this is 25 microfarads at 25 volts. 50 microfarads at 25 volts. Okay. Alright, well that is 50. I was misreading this 25 here. It's 25 microfarads. So we want a 50 microfarad in there. Right, got a 47 microfarad. I don't know where these capacitance values come from. I mean, why 47 microfarads? A little bit specific, that. I mean, I've just taken out a 50 microfarad, which seems very sensible to me. 47? A bit random. Lovely. And just to check, I always leave the capacitor hanging around here to make sure I've got the right way. Negative up there, yep. Positive down there, yes, that's fine. And it doesn't look too bad either, I think, that. And then finally we have this jobby over here, which is 250 microfarads at 6 volts. I've got a 220 at 35 volts. That'll be fine to go in there. It's only decoupling a cathode. Leave that there to remind me. There we go, positive at the bottom, negative at the top. Okay, and that's all the electrolytics we need to replace. Looks quite neat, I think. It doesn't scream out at you, does it, when you open it up? Of course, one could go on and on with these amplifiers. We should be checking all of these carbon resistor values. We could pull every end of all of these caps here and check them for leakage. Quite a big job. I think they're reasonably reliable, these cream coloured ones here. Right, whilst we've got it upside down, we'll give the pots a quick service. There we go. Another job done. Good. What next? Right, I'm going to take this mains cable out of here because that will it needs sorting out anyway, and it will allow us to get to these earth tags a little bit better. I'll just cut that off and remind me where it went. This cable tie can come out too. What else have we got? The lives off, and there's the earth there. I'll just chop that off as well to remind me where it went. I'm going to put a proper cable gripping grommet in this hole here. That's an absolute rubbish arrangement there. Right, I've loosened that one off. Not particularly easy to get to. And this one is just sitting there handily doing nothing, which is rather interesting. I wonder why that's there with nothing soldered to it, and never has been anything soldered to it either. I think I'm just going to put a couple of fresh solder tags in here. Don't need to have this one particularly. The closer they all are to the same point, the better anyway. Okay, I'm going to make up a little kind of star solder tag arrangement here to give us plenty of earthing points. Like so. Washer on top. Shape-proof washer. And a nut. There we go. Just get this spaced out nicely. Right, that's nice. So we've now got a decent earthing point. These two need to go to there, and I'm going to make this a little bit nicer. And we need to bring an earth down from here down to here as well, and we need to put the mains earth onto here. So this is going to be the wire from the dual capacitor down to our earthing point. You have to keep these kind of wires thick if you can, just because of the possibility of picking up hum loops if you don't. I've sorted a few amps recently with quite nasty hum loops on. Chase down the hum. Okay, so that's going to come from there. I'm going to keep this as short as I can, really. I really want it. I might even make that a bit shorter. Right, that's earth number 1. Earth number 2 will be this, I think. Not sure where this goes to. Alright, well that's kind of stripped and goes to here, so I need to remember that I want to put a wire from here to here as well. It's not terribly obvious that it's got a red wire on it, which is not ideal. Must remember that this is the mains in here, neutral. There's a good opportunity to mess things up here if I'm not too careful. All these black wires floating around. I think I'm going to do that first. Let me show you what I have in mind here. Right, I'm going to put a short length of tinned copper wire from this solder tag. There we go. And whilst we're here, we'll solder this one on too. There we go. And this now is going to go across to here, which is the negative of this big smoothing cap here. Yeah, that's good. And that's now a lot neater. So we have mains earth here. We've got a spare place for the mains earth there, so that's good. Right, let me now see if I can find some sort of grommet to fit this. Some sort of cable gripping grommet rather than this thing. Right, I've just fitted a little 3-terminal tag strip here. so that we can get these mains connections cleaned up a little bit. So now we can wire from here off to our various things. This is going to be the earth, and it does go to earth, but I'm tempted to link it to here anyway with a bit of tinned copper wire. Might just leave that until we do some earth tests. By earth tests I mean power it up and see what kind of hum loop, if anything, it's got. So earth, neutral, live. Right, this is our neutral coming in to the mains transformer from the on-off switch, which is currently switching neutral. We want to come off the live terminal and go up to the switch, come back from the switch through the fuse, and then off to the primary of the mains transformer. Right, I'm just going to cut these two here, get them out of the way. Right, we're going to come up here with a well, let's do it kind of logically. Let's come off the live input, which is the third terminal down here. We haven't got our mains cable connected yet. To be honest with you, I'm waiting for the right grommet for the front panel here, back panel. Solder this onto here. Right, we can go off along here with this. It's probably more detail than you want this, but I suppose there's always a fast forward button. Under here, and that's going to go to our mains switch at the front. Good. Out of the main switch, and into the fuse. Like so. We'll tidy this up at some point. I'm just going to put a couple of little bits of sleeving on here, just in case anyone's crazy and insane enough in the future to want to reinstate this the way it was, with the highly dangerous switched neutral. So live in, through the switch, out of the switch, through the fuse, out of the fuse, and into this orange, which is the primary winding, one side of the primary winding. The other side of the primary winding, mysteriously, is this black one that goes in, actually into the transformer. Very bizarre. And comes off of the voltage selector. So let's now sort that side of things out. Okay, I wasn't quite right on what I was doing there, because of course we have the voltage selector here. So what I actually want to do is to come out of the fuse now. This is the primary side. Out of the fuse, into the centre of the voltage selector. It's quite a big rewire, this actually. Right, the voltage selector goes off to the primaries, so that's all correct, and it's just that the other side, the orange now, which needs to go to neutral, so effectively to here. So this is the neutral going in. I've decided to use black for this. I don't like having orange for the neutral. And I've got a fairly long piece of black sleeving here, which I'm just going to pull down over the joint eventually to make it sort of somewhat more black. Right, let's do some basic checks. What we want to be seeing is coming out of the live terminal from the mains in, so that's there. That should go through a switch, so it goes up to the switch there. The switch is on, so it's going through the switch. It comes down and goes to the fuse. Oh, it's this side, wasn't it? Yeah. There's a fuse that side. And then it comes from there through to the center of the voltage selector. So that's to the center of the voltage selector, and it's selected to 240 volts, which should come out here. And then that goes off to one side of the primary. The other side of the primary comes in here on this neutral wire here, and that should go up to here. And it does. So I believe that to be okay now, and we've got our capacitor in, and that goes down to ground. We need to wire the mains lead in at some point, and we're not far off. I think actually we may be ready to turn it on, because good, well, we've made some progress today. I'm quite pleased. Okay, it's been a few days since I worked on the amp, and in the post we have cable gland here, and all the way from Hungary, I think, a 50k 24mm pot. That came next day from Hungary. I ordered it at 12 o'clock in the afternoon, and it came to the UK the following day. Absolutely bonkers. No idea how they did that. So these are the next two things to put in. I think I'll make a start on the cable first of all. Then we'll get this in, and then we are good to go to power the amp up and see if we're getting anything remotely like a working amplifier. Right, now the question is, will this fit in the hole when I take that out? And my guess is no. This is actually quite wide, this. Anyway, let's take the grommet out and see. We might have to do a bit of filing. I love filing. Right, well, complete change of plan. This hole here is a lot smaller than the entrance hole required by this, so it's not just a question of doing a bit of filing. I don't mind doing a bit of filing, it's just that that will make that hole a lot bigger than it originally was, and I'm trying to do as little as possible to this amplifier to change it from stock. The less that's done to it, the more original it is, and the more successive techs that get in here, change this, change that, file out a hole, change the fuse holder, upgrade these caps, the less authentic it is. So I'm going to revert to a plan B, which is to restore the grommet into there, and then I'm going to bring the mains cable out, and I'm going to put a clip down onto the transformer holding here, then bring it round this clip and then up to our terminal board here. And I might also just put a cable tie around here for extra security, but I think that'll do it. So what I noticed the second I put a nut spinner on my transformer here, it was just really loose, and I went to the others and they're all loose too, so the mains transformer all needs tightening up. So I'm going to need to get on the other side of this with a screwdriver, because that's just rotating the entire bolt, and then I'll take that off, put that clip on, and then rejoin you then. Okay, there's the clip in and the grommet back in. I don't mind telling you, that was a very, very difficult job. It took me well over an hour to sort that out. In particular, that grommet did not want to go back in, and getting that clip on there was quite tricky. So I'm now just going to strip these back and solder them onto our tag board here. That's the next job. It's just a little tip here, when you're stripping back mains cable like this, it's not actually very easy to strip this outer off of the inners. And what I've done over the years is I use a scalpel and sort of fairly surgical precision, but the trick is to put some tension on it this way, and all you do is kind of very lightly go along and let the tension of the cable do the final break here. Don't go soaring away inside here with the, see how that broke there? Otherwise you'll nick the insides. So that's just a little tip there. I guess people watching may have their own methods of doing this, but this is how I've always done it. Like that, there we go. And we didn't even mark the inside conductors there. Right, so I'm going to strip these back, get them soldered onto here. Right, that's in. I've put a cable tie here and I've put a cable tie here as a double sort of stop. And that's pretty solid. That you'd have to really lean on that to get that to fail. And we're soldered on here, so actually this is all good to go. Apart from now, the final thing we want to do is to try to get this pot here sorted out. So let's make that our next job. Right, well I guess the first thing to do is to see if this pot actually even fits in here. Yep, that fits reasonably well. That's certainly good enough. Good. Well, before I put that pot in, I just noticed we've got another problem here, and that is this wire flapping around here. And we don't know where that goes to. I've stripped and tinned that. That was just cut off there. So we need to do a bit of detective work here. I spent a bit of time on it. Let me show you what I've found. So it goes to the junction here of this electrolytic capacitor and this 1 meg resistor, the negative side of the electrolytic capacitor and the 1 meg resistor. And I believe it to be a ground. In other words, that should go to chassis. Now, quite why it's taken over here, I don't know. Maybe did it go to the back of this pot for some reason? It doesn't quite reach over to this pot. So on the schematic, which seems to be quite accurate, although the layout diagram is not very good. So here is our electrolytic capacitor. Here is the negative side of it. Here is a 1 meg resistor, and as you can see, this is actually the ground. Just to be absolutely certain this is the right part of the circuit, this is the tremolo part of the circuit, by the way, the positive side of that capacitor goes to the cathode of this ECC83. So here's the positive side of this capacitor, and it goes to the cathode, which is 1, 2, pin 3 of that ECC83, which it does. So that's the right capacitor. I believe that to be the ground side. It's not currently grounded, look. The layout diagram doesn't help because it's not exactly the same as this. It's similar. This is part of the circuit. This is probably the same capacitor here. Here's a ground, look, going to ground. So we're in the same sort of kind of region here, although this doesn't exactly mimic this layout here. It's the same kind of circuit. So, you know, this is the ground wire. It's taken back to star earth on this layout. It doesn't go to any star earth, so maybe it just went up to the fact that it's hanging off. Does that mean it was on the back of this pot here? I don't know. Slightly concerned about that, but anyway, what can we do apart from put the pot in now? So here's our diagram here. We're going to put the pot in like this. So the back of the pot has 3 terminals. We're looking from the rear and above. I'll put here rear, above. Right, now fully, so the centre goes to the foot switch. So that's quite easy. That I believe to be this black one here. I'm going to have to remake all this. We can now mark on our diagram that this is black screened. Good. Okay, now what else have we got? We've got a 33k resistor going to the screening on here. So I'm going to take a 33, and that 33k resistor is with the intensity at minimum. So with the intensity at minimum, the pot's all the way around here, down, so that's connected to there in the minimum position. And so we want our 33K on the minimum position down to ground. So on here, we want a 33K to ground. And on the other side, what we might call the maximum side, we want this 10K and 0.1, which is this here, look. So this is our 10K and 0.1 capacitor. So here is our 10K and our 0.1, I think, whatever it is. And then I'm going to scrape off the back of here and put some solder on there, and we're going to reconnect these wires here, which are the ground wires. Good. Right, well, let's make a start just by cleaning off the back of the pot. I'll also put a bit of flux on there, I think. Now, that went quite easily. May as well tin these whilst I'm here. And let's also tin these whilst we're here. There we go. Now we can, I think we'll fit the pot actually. I think it's probably the next sensible thing to do. It's quite difficult to get onto in there, under there. I think the next thing I'm going to do is to strip this back. This black wire is rock hard here, and this is a right mess. This whole lot here. That screen's about to fall off there. There you go. And we've got a bit of cable here, so yeah, we've got room to strip that back. So let's do that as our next job. Okay, we can do a bit of work on this with the pot outside of the amp. So for example, we can put this 33K resistor in. Just following our little diagram here, 33K resistor down to ground. So we'll put that down to the, there we go. That's that. And so that goes there. Oh yes, I suppose we're going to put this one, this white one, I guess we're going to put to, the length of it is suspicious. It's almost like it came off of here. Yeah. Well, I don't think we've got a lot of choice really. I think I'm just going to put this to ground as well. Bit of an odd one, this. Why they've brought the ground right the way across to this pot, if indeed they have. Okay, so we have remade this. This took ages because this is one of these tightly braided screens where you have to pick it off with a very fine pointed implement. Anyway, I'm going to strip this with a soldering iron, which is a bit of a technique really, but saves the possibility of nicking the inner wires, especially on a very short lead like this where it's hard to get the wire strippers onto it. And the black goes on to the middle, and I think we'll take the screen down to here. Like so, and this can go to here. trouble with that is that'll pop off as soon as we try to solder these bits of wire here to it. But anyway, let's see how we get on. I think we're in a stage now where we can put the pot in. Right, will this work? No. No. Oh wow. It actually worked for the first time. There we go. It's a bit tucked away underneath there for you, can't really see it, but anyway, all we have to do now is to tack this one here, this red, this 10k resistor onto the other terminal there, and then see if we can get these grounds in. I think this is one of the reasons why it's difficult to kind of make a living at it, or to find someone to do this work, because to do it commercially you would have to charge quite a lot of money, and the average amplifier isn't worth a huge amount of money. This one is, as it happens, but in the average amp, 500 quid, 300 quid, 600 pounds at the most, and then you come in there with your 5 hours work at 40 pounds an hour is 200 pounds plus parts. You're in for a start to get into a bill which is worth more than the amp, or certainly which the customer starts to wince. And with most businesses, you occasionally get a nice one where you can make quite a bit of money on whatever it is you're doing, and the customer doesn't mind. But you can never do that with amplifiers. There's never a time when you can make hundreds of pounds on a job. Ouch! It's all X pounds an hour plus parts. You do it for the love of it, really, plus a drink. I mean, the other thing, if you tried to make a living out of this, it gets a bit depressing, really, because what does success look like? Well, it looks like 8 in the morning till 7 at night in the workshop doing what I'm doing here, without any daylight, just slaving away, next amp, next amp, next amp, making £39.50 per amp, and at the end of the day you've made 200 or 300 quid, which is enough to pay the mortgage. So righty ho, not sure whether this is a good idea, but anyway, I've got the meter set to DC 200 volts and I'm clipped across the HT. So basically what I'm looking for is, as I wind this up on the variac very slowly, I'm looking for a bit of HT to come out of here. Now it'll take a while because this is a valve rectifier, so I've got 50 volts AC going in to the amp. We haven't got our front indicator connected yet. I'll do that when I'm happy all the voltages are there, and I'll find 6.3 volts somewhere and connect that on. So we've got 50 volts, no sign of anything at the moment, but then I'm not really surprised. The rectifier has to get warm before anything will happen. Let's turn up a bit more. Nothing is happening on the variac, we're not drawing any current, so 100 volts AC going in and no current being drawn particularly. I'd like to see this start ticking up. That would make me happy. As the rectifier valve warms up, try a bit more. Let's go up to 150. Okay, not looking terribly promising. In a minute I'll start tracing the AC through to make sure we're getting voltage on the AC side of things. So we're up to 200 volts going in now, and nothing's happening. Okay, there was a loose connection in the mains plug on this amp, so I fixed that, and let's try again. So back onto DC on the HT side, and bring up the variac to 50 volts. No current being drawn on the variac, so I think we can safely go to 100 volts. No DC. Okay, let's come up a bit. The rectifier valve will need to get reasonably warm before anything happens. No sign of any glow on the valves either. Let's come up a bit further, but it's not looking promising, so we're in the same situation. Right. Okay, let's put it back down to 100 volts. Go to AC. And once again see, do we have 100 volts coming in on our mains lead? Yes, we do. Okay, so going from neutral now Do we have 100 volts either side of the fuse? There and there, yes we do. Do we have it either side of the main switch? Yes we do. Okay, do we have mains voltage across the primary of the transformer? Now that's between here, and unfortunately this winding here disappears into here, which is a bit weird, but there anyway. Okay, I've satisfied myself that I do have 100 volts on the primary of the transformer. It took me a bit of time to trace that through. And when I go on to the heaters of the preamp valves, look, I've got 2.5 volts AC. So that's looking good with 100 volts going in. If I turn that up a bit more. Okay, it seems to have sprung to life a bit. There's a very low level, difficult to describe sound going on. It's very quiet and it's like a sort of creaking, a constant creaking sound. A kind of sort of sound, very low level. I've got 165 volts at the moment. But anyway, look, we've got some HT. There, 245, that's great. And we've got some on this cap here, that's good. And the output tubes are warm, so that's good. And we've got 4 volts on the heaters, so that's all kind of looking fine really. So I'm happy that the primary is all connected up correctly and the windings are about right. What I don't like is this creaking noise. I'm just going to plug a speaker in and see if I can hear anything. Oh yes I can. Right, so the amplifier I think is oscillating. When I plug a speaker in, okay, the amp is oscillating when that's turned up. We've got all sorts of instabilities here. Oh dear. Got myself a synthesizer here. Right, I'm just going to try plugging a signal in, see if there's anything even remotely resembling amplification going on here. Nothing obvious. Sounds quite live, the amp. You know, it sounds like I'd expect to hear it with a kind of, you know, live buzz sound to it, but there's nothing whatsoever happening on the inputs. It's surprising that, because when it's in the non-oscillation mode, it sounds very live. You know, it sounds like any minute now that could. Okay, so that's bad news. There's not a peep coming out of this amp really, apart from oscillations, which is a bit peculiar really. Well, greetings again. It's been 2 or 3 weeks since we last looked at this amp. To be honest with you, I put it to one side because after doing so much work on it and having it oscillate, I got a little bit despondent. That can definitely happen from time to time. Just to remind you, it's oscillating. I've got it on at the moment, and if I turn up the volume, yeah, I've got a nice little oscillator there. Now, what I noticed, the odd thing about this is that when it's not oscillating, I just back that off so it doesn't oscillate. There's absolutely no sound coming through this at all. I've got a tone generator in here at the moment on quite a loud setting, and there's not a peep coming out of the speaker. Literally zero. So there's something a bit weird here. There's no point in pulling valves or anything, because with an oscillating amplifier they're very difficult to sort out, because anything you do will stop the oscillation just like that. If you pull a valve, it'll just break the loop and it'll stop the oscillation. So I'm going to focus on stage 1 here, because I'm a bit curious about why no signal is getting through. You know, I'd expect a horrible distorted signal at least, or anything, but there's not a peep coming out of this amp. Now, when I was at university, my old lecturer, George Whitfield, long ago passed away I'm afraid, great guy, he always said to me, and it's ringing in my ears now, check your DC conditions. So in other words, don't get involved in AC stuff until you've got the DC conditions correct. So that's what we're going to do now, starting at stage 1. And I want to check first of all, are we getting any HT on this first valve? Because my intention is to put a signal in and start tracing it through. Let's have a quick look at the schematic first, just so that you can see what we're getting involved in here. It's a very simple input stage. 2 inputs there mixed together with 68k resistors, 2 inputs here mixed together with 68k resistors. They both go to 2 separate halves of the ECC83. If you remember, the ECC83 is 2 valves in one envelope. So here's valve 1 with its first 2 inputs, and here's valve 2 with its second 2 inputs. And we pick off the outputs here off these 100k resistors, and they go off to their respective volume controls here, volume 1 and volume 2. So I would expect to see a signal on pin 1 and pin 6 of this valve. But before I do that, I want to have a look to see if we've got any HT here. If this valve's got no HT, nothing is going to get through it. So let's have a little measure here on pin 1 and pin 6 and see if we've got a decent 200 or 300 volts there. Well, this is actually very easy with a layout like this. It's just so simple. Here are our 200k resistors. They're different for some reason. There's 100k, there's 100k, and they go off to pins 1 and 6 of the valve. So we can just easily, and there's the HT coming in, so we can easily measure here to make sure we have got a couple hundred volts at least on the valve. Without that, that valve will never work. And so we should have, now that's interesting. Did you hear that? So immediately we've got a signal going through. It's a noisy signal just caused by me touching this, but listen to this. So this is all live here. Right, what have we got? 300 volts, that's perfectly alright. Happy with that. Should get a signal here too then. Yep, we do. And we've got 300 volts there. So the valves are live. Don't be fooled by the fact we're getting a signal when I touch that. This is the output of this valve, so this is going downstream to this valve here. So this doesn't prove that this valve is working at all. It just really proves that the rest of the amp is working. There we go. If I was to get a tone generator and a capacitor, I bet you I could inject a tone there and the amp would work. So that's actually quite encouraging. So we've got DC. Well, let's see what the HT is doing, because you can tell whether the valve is actually on by the fact there should be a volts drop across these 2 resistors here. So I don't know, that might be at 350 and this might be at 285 or something. We need a current through these 2 resistors. So what were we looking at? It was 303, and what's the HT? Aha! This is very significant. So 305 and 308. There's no current worth talking about going down these resistors, which means this valve is not on. In other words, it's hard off. That's why we've got nothing coming through it. Okay, so let's go back to the schematic again. Couldn't be simpler, this circuit, really. So no current is coming down these resistors worth talking about. So no current is flowing through the valve and through this 820 ohm resistor. So the valves are off. Both of them are completely turned off. Right, alright, so this is interesting. There's one thing left that it could be. I'm going into some detail with this for you because it's useful to learn a little bit of theory as you go along. We've got no current going through the valve. The valve is off, but these are correct at 0 volts. These are correct at 300 volts. So there's only one other reason why current wouldn't go through the valve: if this 820 ohm resistor was open circuit. Just imagine removing that. Well, current can't flow through the capacitor, the valve is off. So I've got a feeling that 820 ohm resistor might be open circuit. I'm just going to turn the amp off to let the voltages die away, and I'm going to measure that voltage. Right, well, let's have a look at that 820 ohm resistor. Where is it? It's here across the capacitor, very plainly obvious there. And we can, I'm kind of betting that might be open circuit. By the way, I'm feeling a little bit more optimistic here, because with this stage not working at all, if we get it working, it might cure the oscillation. I hate oscillating amplifiers. They're right pigs to sort out. Right, what are we doing? Let's go on to resistance. 2K is okay. And go from here to here. Oh dear, that's a shame. Okay, 820 ohms it is. So it's not that, and it's not short circuit capacitor because we would have got short circuit if we'd gone across there. There's not much left. Either this is broken between here and here, or that's broken between here and ground. Let's have a look. I hope one of those things is true, otherwise I'm out of ideas. Right, continuity. So here's the junction of the two cathodes, and that should go to here. It does. Short circuit. Well, the only thing left is this has to go to ground. Junction, a negative of that capacitor and the 820 ohm resistor. Negative of that capacitor, 820 ohm resistor, go to ground. Ground. It's just what I'd expect, and they don't. Is it me being silly? No, that's on there. That's the problem. The ground is picked up by this black wire here, which goes up. I can actually see where it goes to. It goes to a pot here, soldered on the base. Let's see if there's any continuity between here and here. No, there's only a black wire. Excuse me. Is this off, this amp? What will I just found? Ta-da! This wire here was dropped off the bottom of here. I guess it possibly dropped off when I soldered that capacitor in. Yeah, I bet that was me. I bet I did that. I bet that when I soldered that capacitor in, that wire came off and I didn't notice it. It just fell underneath like that. Alrighty, well let's put that back on. Just going to check the amp, the voltages for the moment, make sure we're not going to kill ourselves. Go over on the HT over here. No, there's nothing there. Good. Right, okay, well. Right, let's put this back on. I shall be a happy bunny if this amp springs to life, I don't mind telling you. Right, well, what do you reckon? Moment of truth. Let's plug a guitar in. Right, turn it on. Wait for it to warm up a bit. Oh well, there we have a signal. Oh wow, so quiet. That wasn't even a hum there, that was amazingly quiet. Well, that's working, folks. A rare chance to hear my virtuoso guitar playing. Well, that has absolutely made my flipping day, that has, I don't mind telling you. So let's just check it's not oscillating anymore. That's up full, that's up full. Let's check the second input. Works absolutely fine. And it's dead quiet. I thought it wasn't working when I turned it on. There's no hum. Well, I'm punching the air, folks. All that work and that amp has now come to life. I hope you enjoyed that little bit of fault finding there, because although it was my silly fault that came off, that's exactly how we fault find. We go through 1, 2, DC, 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 woo, ooh, nothing there, and start tracing back. I was a little bit unlucky that was tucked underneath there and looked up for all the ward like it was connected. Had it just been flapping around loose there, I would have spotted it ages ago. Right, now what we don't know, of course, is is the tremolo working or anything like that. So I've got the tremolo valve out at the moment. Since I'm feeling lucky, I think I'm just going to plug that tremolo valve in and see. We should be so lucky. Okie dokie, no luck on the tremolo. I've got it turned on. I've got the tremolo valve back in, and when we play, nothing on the frequency or the intensity. Let's do the same sort of thing. Let's check some DC conditions here. Right, here's the oscillator valve here. Only half of it's being used. DC, what have we got there? 100 and... Oh, that's interesting. Okay, that's interesting. You see that going up and down? I'm wondering if the oscillator is working. Would you believe that's oscillating nicely on the scope? I'll show you that actually. Before I do that, let me just change the frequency. Oh yeah, frequency's working. Oh right, well, this is interesting. Right, so let me show you. There you go. That's a nice, you know, I don't know, 5 Hertz, 10 Hertz, who knows really, frequency there coming out of the pin 1 of the valve. And as I turn up the frequency, look, it gets faster. As I turn down the frequency, it gets slower. And that's quite a big signal too. That's 50, 60 volts peak to peak there. Turn it up, gets faster. That's actually working. Well, that's very good, because if oscillating amplifiers are difficult to sort out, non-oscillating oscillators are equally difficult to sort out. So our oscillator is oscillating, which is great. This is oscillating here. We've got a nice big signal here. I've got to show you this. Oh my god, is it my lucky day or what? Okay, I put the scope on here, and we know we've got the signal, the oscillator signal. I put it on here and we've got the signal. So I thought, okay, well, we'll put it on this capacitor here. And as I put the scope on there, I actually heard the signal come through. I can actually hear that in the background, and look, it's unsoldered from there. Look, this capacitor is unsoldered. So I'm going to solder that on there, and with a bit of luck, you never know, might actually have a tremolo. That would be another flipping miracle. Well, have a listen to this, folks. We have tremolo there, frequency, intensity, can you believe that? That all actually works perfectly. I'm delighted. Can hardly believe it. And it's so quiet, this amp. Whoa. People, I'm packing in for the night. I'm going to have a well-deserved pint of beer and something to eat, and I can sleep easy tonight and pick this up in the morning to do the final checks, like the bias, and if you remember, we've got to wire this indicator light in somewhere. Final checks, and this beautiful amp is good to go. Okay, I'm just going to put these two KT66s on my tester to see if they are a balanced pair, and whether or not we need to replace them. I've checked all the preamp valves. They are all good, even though they are quite old. Okay, I put the valves on the tester, and they're not brilliantly matched. They are within 4 or 5 milliamps of each other, and I think that's okay really. Anyway, let's turn it on and see what the bias is doing. I've got my bias meter hooked up to the lower current of the two valves. I'll just turn on. There we go. Of course, it's got a rectifier, so the HT is slowly coming up. And there's the current coming up on the valve. Nothing alarming there. So that's going to settle down at, what, 27 milliamps or something. Right, what I need to do now is to check how close that bias is to optimal. It doesn't look too far off to me, but I'm not using KT66s commonly, so it's just not in my head. that won't be a mile off. And we're on the low current one at the moment, so the higher current one might be reading, I don't know, 35 or 34 at this particular junction. So let me go away and see what the bias current should be for 444 volt plate on a KT66. Right, I've just looked it up on the Ted Weber bias calculator website page, and the correct bias is about 39 milliamps, so about 10 milliamps more than this. So I think I want to bring this one up by about 6 milliamps, and the other one will come up by, closer to 39, and that will be fine. So we now have to work out how to bias this, which won't be difficult, but we do need to think about it. So once again, I'm going to need to turn it upside down so that we can get to the bias components. Okay, the schematic isn't great in that you can't read the values very easily. I've been on the internet, it's nothing to do with this blow up here. This is exactly how it looks on the screen. Anyway, look, the bias is derived via this diode here and this dropper resistor, this 150k. It gets smoothed by this capacitor here, which is the one we changed. I'll show you that in a moment. And then it gets kind of potentially divided by, I'm not sure what this is, I can't even read what that is. Anyway, I think that's 15k and something else here, I don't know. Oh, 56k, I see. Divided there and then picked off, look, to feed off to the two grids for the negative bias voltage, having been smoothed again by this capacitor. So we want more current to flow through here, which means we want the bias to be more positive, which means we need to reduce the value of this 56k resistor such that this becomes less negative. Remember, this is a negative voltage here of a minus 60 or minus 70 volts here, being potentially divided by these two resistors. So if we take this one closer to ground, this point here closer to ground will have a more positive voltage, and that will give us what we want. So let's see if we can identify, I think, a 15k and a 56k. Yes, well, actually we can. They're straightforwardly here. Let me show you. So there's the 15k, look, here, and there's the 56k. So what I'm going to do is I'm going to clip my resistance decade box across this 56k and dial in a resistor which will give us about 35 milliamps on the one valve which is currently drawing the lower of the two currents. So let me do that now. Okay, here we go. I've got the resistance decade box clipped across the 56k. Let's turn it on and get it warming up. I've just selected randomly 270k at the moment. Maybe I'll make that a little bit bigger, actually, 370. Up comes the HT as the rectifier valve warms up. This will start drawing current now. And we're looking for about 34 milliamps on this cooler of the valves, which will mean the other one will be drawing about 39 or something. That was already up, look, so even this 370k has made a big difference. So let's go up to... That's very sensitive to the value of this. So 560k gives us nearly 40 milliamps. I think that's a little bit hot. I think I'm going to try 680k in there. I'm really looking for about 34 milliamps here. It's amazing, isn't it? 680k across 56k is really makes a big difference to the current. Here are the two smoothing capacitors we put in, by the way, for the bias circuit. I think they were 10 at 100 volts. So still too much. 820k. Let's just try nothing. Yeah, God, that is very sensitive. That's amazing how little resistance you need across there to make a difference. Well, 1 meg? Good lord. It's rather surprising. So there's 1 meg. What is it without anything? Yes, 30 milliamps as we suggested. 1 meg across there, look. Gives us our 35 milliamps. That's really amazing. So I've decided to go an alternative route, which is to put a resistor in series now with this 15k resistor. And I think we'll get a lot more control. So I've got the resistance decade box again. We've got 30 milliamps, look. And if I put 1k in, we get 30.5. So look, this is looking a lot more controllable. Let's put a 10k in there, and we've got 36, 34. Oh, it's okay, 33. So this is looking much more like it. We want about 35, if you remember. So let's try 12k. Yeah, this is probably close enough. 15k maybe. Yeah, 15k. So if I put another 15k and that will get the bias right. 35 milliamps on one valve and about 39 on the other, and remember we're looking for 39, so I think that's good enough. Right, there we go. I've popped in that 15k. It's not particularly pretty, but I'm not overly worried about that. I want people to be able to see this is obviously a bias adjustment resistor here. If they ever wanted to tack that one back in, they could. If they ever wanted to adjust the bias again, they could go straight to here and say, oh yeah, I see what they've done, and replace this resistor here. So that, anyway, that's fine. Let's turn it on and see if, having replaced the resistor, the bias is still as we want it to be. Up comes the HT, up comes the bias current, and we're looking at, if you remember, we're looking for about 34, 35 milliamps. Yeah, that's creeping up there. 32, 33, yeah, that's absolutely fine. I've got no problems with that whatsoever. Good, that's amp biased. And we didn't have to change the valves, which is great. That's another expense saved for the customer. Quite expensive, a decent pair of KT66s. Right, the only thing we have to do now is this indicator lamp, which we've left absolutely to the last minute. Right. Okay, I have put the power supply on these two wires here at 6 volts DC, and the lamp glows perfectly right, so the correct indicator is in. And I think the best place to pick up the 6.3 volts is just on the heaters of this valve here, on heaters of the tremolo valve. So I'm going to tack this onto there, and hopefully we'll have an indicator bulb, and hopefully that'll be the last job on this amp. Okay, I think it's rather fitting that the last job we do on this amp is to get the indicator lamp working. Ta-da! Ooh, that's pretty. Okay, we're going to do a final check here on the power output of this amp. So what I'm going to do is I'm going to turn this up until the output squares off. Now I've got it connected to a dummy load, which goes into the speaker output, and I've got a scope connected across the dummy load measuring here. This says 1 volt per division, but I've got times 10 probe on, so it's 10 volts per division. So let's see what happens as we turn this up. Count the divisions. Squaring off there, look. 1, 2, 3, 4 divisions. 4 divisions. Okay, turn that down. Don't want to thrash that too hard. Right, let's see what 40 volts peak to peak is in terms of watts. Right, I did a slightly more accurate measurement of the power output, and it's giving about 29-30 watts, which is not bad. I believe this is only a 35 watt amp anyway. I think part of the characteristic of it was that it broke up quite early and gave a nice kind of bluesy sound. So I think we can call it a day on this. Obviously you can go on and on and on with an amplifier and rack up dozens and dozens of hours of work. And we've done a fair bit on this, I think you'll agree, and it's now working, which it certainly wasn't before and probably hadn't for many years. So I'm going to call it a day. I'm going to pop it back into its box, and we'll have a last little test of it to see how it sounds. Well, there you go, quite a marathon that one. I seem to have been working on this amp all of my life, but we got there in the end, and I hope you agree, very, very interesting and unusual and quite rare amp to be working on. That's fantastic. Well, I'll leave it there for now. I'm going to play you out on this amp, because I know I don't normally play amps because I'm not a guitarist, and of course you can't hear tones or anything coming over the internet, so I don't really see as much point in listening to an amp, but this is such an unusual one. I thought we'd just finish up by playing a little bit on the guitar and see if you can see how it sounds. So as always, thanks for watching. I'll catch you on the next video. We've got a little bit of high-speed tremolo on. Maybe just try and get a bit of break up. That sounds quite nice on the break-up, probably sounded terrible to you with that distortion, but there you go. There's the Bluesbreaker.